Welcome. In this lecture, we're going to talk about all molar conversions. We're going to take all three of those different kind of conversions that we've done, and we're going to put them all together. And this is really what you need to be able to do with this. We know that 1 mole is equal to, that's not what I wanted to do, 1 mole is equal to 6.02 times 10 to the 23rd particles. 1 mole is also equal to the molar mass. 1 mole is also equal to 22.4 liters. So the nice thing is, since all of these are equal to a mole, all of these are also equal to each other. So I can convert from particles directly into mass. I can convert from volume directly into mass. I can convert from volume into particles. And all of these, obviously, we can convert into moles. So let's do our first example here. So here it is. What is the mass of 26.4 liters of CO2 at STP? You don't need to worry about this at STP. Remember that our 22.4 liters, this guy right here, is only true. 1 mole of a gas at STP is 22.4 liters. So this is just confirming, yes, we're at STP. So we need to figure out, what are we converting? From what into what? We are converting from volume, right here, into mass. So volume to mass. So we pick out the two conversion amounts that we want. We're going from volume, that's this guy, 22.4 liters, into mass, molar mass. So I need the conversion 22.4 liters of CO2 is equal to the molar mass of CO2. And if you look at your periodic table, you've got 1 carbon at 12 grams, 2 oxygen at 16 grams apiece. The molar mass of carbon works out to 44.0 grams. You are going to have to find that again when you're converting from mass or into mass. So this now is the conversion equation that we're going to use. So we just set it up. We are converting 26.4 liters of CO2 into mass. So we're multiplying by a conversion fraction. Now, let's see here. I've got 22.4 and I've got 44. Which one goes where? I've got liters on the top right here, and I want that to cancel. So my 22.4 liters is going to go on the bottom. My 44.0 grams is going to go on the top. Liters on top, liters on bottom, those cancel out. And now the dimensional analysis. And we're going to do top times top and divide it by the bottom. So 26.4 times 44 divided by 22.4. And we throw that into the calculator, and we end up with 51.9 grams of CO2. So there we converted a volume into a mass. We could skip completely converting it into a mole and then converting it into a mass. We could have done it that way. That's the long way. That's the hard way. Do it this way. Identify what you're converting from what into what. Then identify what that conversion equation needs to be, set up the conversion, and do the math. All right? Let's do another example. So here it is. 15.2 times 10 to the 24th particles of H2O is what mass of H2O? I have our lovely 4-part conversion equation at the top here. And let's see, I'm going from particles into mass. So that means that I'm using this, 6.02 times 10 to the 23rd, and I'm using this, the molar mass. All right, so our conversion equation is 6.02 times 10 to the 23rd, and this is a covalent substance, so it's technically molecules of H2O, is equal to, we have to go to the periodic table and find the mass of H2O. 2 hydrogens at 1 gram apiece and 1 oxygen at 16 gives us a molar mass of 18.0 grams. So now we set up and do the conversion. We've got 15.2 times 10 to the 24th molecules, and we're going to multiply by the conversion fraction. We've got molecules on top here, so we need to put molecules on bottom. 6.02 times 10 to the 23rd molecules. And that's equal to 18.0 grams. Molecules on top, molecules on bottom. Now we do the math. So we've got 15.2 times 10 to the 24th multiplied by 18.0, the whole thing divided by 6.02 times 10 to the 23rd. And we're going to end up with 454 grams of water. And that's it. Those are the basics. So go back to your problem, identify what you are converting from what into what, then go to our lovely four-part conversion equation, figure out which of the two of these you need. Is it the mole? Is it the particles? Is it the molar mass? Or is it the volume? Use that conversion equation, do the dimensional analysis, and solve. Write out your work. Show this in the dimensional analysis. All right, you need to show that work because you need to show that you put the right thing on top and the right thing on bottom. Do not guess what you are multiplying, what you are dividing. All right, show the dimensional analysis, show the units canceling, and always, with your answer, provide the units. All right, that's it. See you next time.